Hello, everybody. Welcome back to the Goosenov Show. Today, we are going to talk about future warfare and how it could probably go. So, just some background. I have studied mechanical engineering and product design for around 5 years. I got a Bachelor of Science from the University of Colorado Boulder, and then I have a Master of Science from Columbia University studying basically mechanical engineering with a concentration in robotics and control systems. And I also have experience with, how would you say it? Designing stuff for defensive purposes. Anyway, but we're going to approach this from more of a kind of a game theory lens and kind of look at the speculative nature of what future technology would bring. So if we look at how drone warfare is operating right now in Ukraine, I would say it's still in a very, very primitive state. Basically, what you see is a bunch of COTS drones, and that means like commercial off the shelf. So basically just drones that are, sold to the civilians that are being repurposed with 3D printed type modifications or, some basic stuff in order to basically, drop grenades or just detonate like some sort of small explosive. So suicide drones have pretty much dominated the market right now in terms of the current battlefield. But the problem is that I'd say they're still very primitive in terms of what they are. You have basically with Russia, you have two different second world economies that don't really have a great industrial base, that have to leverage the industrial bases of other countries, more or less. Russia kind of relies on, everyone relies on China, but in the Soviet Union, you had like a vertically integrated supply chain. But the current Russia is not the Soviet Union. They don't really have that type of great supply chain. So basically, what I'm trying to say is that the Russian and Ukrainian economies are not optimized currently for total war, which is why they need to rely on commercial off-the-shelf drones for fighting. So what would happen if you had a entire economy optimized in a vertical total war scenario? Let's say you had a situation where you had basically China versus the United States, and this is probably an unrealistic scenario, but let's imagine like it's a total World War II level war between these two force-on-force actors. What would that look like? So basically, to understand drone warfare, you need to understand that there's two major types of drones. The first type of drone is like a swarm drone. So these are very lightweight drones that are basically, how would you say it? Expendable, like suicide drones. The reason why these win on the battlefield is because you have a lot of them. And the other problem is, I guess, the smaller and the cheaper something gets, the less maneuverable it gets, the less, how would you say it? The less strong it is, and I guess the more you need to like overwhelm an enemy. So what that means is like on the most extreme level, the cheapest munition you can use on the battlefield is a bullet. And those are super cheap, like $1 or less. The problem is to make them usable at all, they need to be fired by a person or some sort of turret or something. So it needs to be leveraged by something else. So bullets alone are not, they don't work on their own. But one step above that is an artillery shell, right? And an unguided artillery shell that goes from point A to point B. And that's basically, we found out in World War II, or World War I was, I guess, that was the dominant thing, right? The goal was just overwhelm the enemy with as many artillery shells as you can, and eventually one side is going to break. The problem with that is you're basically shoveling a ton of money into unguided munitions where you're just trying to basically, you're guessing at, how would you say it? It's a guess if it's going to hit. On the flip side, you have extremely accurate, precision drones or precision weapons. And the most accurate would be a fighter jet. So what is a fighter jet? It has a human being in it that is controlling precisely where the jet is going, how it's attacking, and then you have like probably precision munitions as well. You could even going into, like ancient tech, like the Stuka. Even that is a kind of more or less like the closest you can get to a precision-based, aerial combat vehicle where, it's dive bombing and it can, destroy a very specific targeted area. So let's go back a second. Why do we even care about, how would you say it? The ability to target a small area and, destroy something accurately. Why does that even matter? Because it's mainly a matter of efficiency. So if I am destroying a large area and, how would you say it? If I'm destroying a huge area, but my enemy is in only one spot, then I destroyed all this space for nothing. So it's basically a bunch of wasted energy. The more efficient scenario is where you just destroy the enemy there. You don't destroy anything else. In the war on terror, the other reason why you focused on, destroying only a small area is also kind of humanitarian, or our kind of just war approach, where we said, we got to minimize civilian casualties and we need to, you got to have a kill chain and blah, blah, blah. So there's like the current U.S. doctrine is looking at it kind of from an ethics perspective. But even deeper, it's basically just a matter of like, I guess, economics, not to get too morbid. It's like, you want to make sure that you're wasting the least amount of energy possible. The problem with precision is it requires intelligence. It requires a control system. Before the advent of the transistor and like really efficient electronics, post 1950s, you needed to have human beings be that intelligence behind munitions. But today, we have single board computers and microcontrollers that are really tiny and really inexpensive. And basically you can use those to act as an intelligence behind your munitions. Which is why, I guess, drone warfare is going to be, the next meta. why couldn't this have been a meta in World War II? Because we didn't have like really great precision. We couldn't make these types of drones. We didn't have the technology. You would basically need to put a person onto a flying bomb and have them direct it. And the Japanese they did that for they did that with kamikazes, and they did that with these like human torpedo things. I don't know if the Germans did that too, but anyway, that was drone warfare in World War II. They needed to use a human being as a computer. But today we can just use an integrated circuit to do that. Because the technology is here, and it's just getting better. So, you could probably, really make an efficient circuit that is able to do most of the control things, and maybe produce it just for like pennies for each IC. The problem is the simpler you get, the less kind of intelligence. So all this stuff is just economics, right? You could put a supercomputer onto these control, or you can get a supercomputer to control one of these things, but then the munition would cost a lot. You could get something made with like 3 resistors and 3 inductors and 3 capacitors, which gives you some weird approximation for less than a penny to produce, or let's say a penny. I don't know. You could get the price really low if you're doing it in huge bulk, but it wouldn't be very accurate. So you're still dealing with some sort of trade-off. The U.S. military currently, its primary, strategic approach to this is erring on the side of, huge investments rather than really cheap investments. What does that mean? It means that pretty much all of the solutions around the war on terror era have been, how do we make the shiniest, best quality, flying munition possible? Which ended up with like the F-35 and, the Reaper drone and like all these different types of drones. And then an $100,000 surface to or air to ground missile or ground to ground missile or whatever. Because I guess we could afford it. I mean, the United States, the world's largest economy versus a tiny economy in the Middle East. They said, why don't we just, shovel a ton of R&D into really expensive weapons that do the job really well? Why not? Why not? If we're going to win, it's you got to imagine it as if the United States has creative mode and we are fighting, we're fighting a player in hardcore mode. Basically, it's like, why wouldn't you use the best thing you can? The problem is that kicked consequences down the road because, we could afford it we thought we could afford it at the time. We have this shiny monetary policy. We can just print money. We can print infinite money forever. So let's just invest everything we can into this. But that ended up in like huge inflation. That ended up in us spending trillions of dollars on these wars. And eventually, every American today is paying for that. You're paying for it through like a phantom tax. Basically, every paycheck you get is worth less and less and less, because that's kind of how we paid for these wars. We printed a bunch of money, we used monetary policy, we extracted value from our dollar, from our system, and the generations a decade ago and beyond were basically taxing us today to get the results they wanted. So anyway, that's just a little bit of the economics of how this warfare goes. The problem is, if you have a force-on-force conflict with peer adversaries, meaning China versus the United States, you don't get to play this little magic game anymore. You don't get to say, oh, we're going to spend a ton of money on really shiny gadgets. You actually need to care about the engineering, like a lot. And, well, I would say that our current approach of spending a lot of money on a really shiny weapon isn't optimal given this scenario. But we're still investing in it. Anyway, we'll see. We'll see how it goes. So let's see here. Why doesn't this work? Why doesn't this work on a peer-to-peer battlefield? I would argue the reason this doesn't work is because you end up using your munitions really, really, really fast. If you look at the conflict between Israel and Iran a couple months ago, what you basically saw was Iran, launched a ton of their old stupid missiles at Israel, and Israel spent a ton of money on, what do you call it? Intercepting a bunch of them with their, really high-tech interceptors. And from my understanding, Israel, they used up a significant amount of their interceptor stockpile. And these are expensive. So if you just look at the economics of that, an old adversary is launching cheap missiles at you, and you're spending more money to intercept them. How that ends up working out is that they end up completely overwhelming you. If they just keep throwing cheap stuff at you, eventually you're going to use up all your interceptors, and then you're a sitting duck. Unless you make really cheap interceptors, in which case, you could keep that up indefinitely. But that's not, I guess that's not how, the American side has been investing. So what does this look like in China? And there are studies on this. There are military war games that have been done on this. I suggest you look these up. But basically, if there was a peer-to-peer conflict, most of your advanced munitions, or all of them, are used up within a couple of weeks. And then what happens? Once they're all used up, what do you do? We're just going to make more. Okay. You've been making these, you've been slowly building these up over the course of years. It takes a long time to produce these really advanced munitions. Like, how long does it take to build a fighter jet? How long does it take to build an airplane? An advanced airplane. Long time. Especially with our current manufacturing system. Like, America right now is, how would you say it? Its economy is based around boutique manufacturing. If you look at the Rust Belt, we used to be really good at, mass manufacturing. We were churning out cars. We were producing tons of steel. We were building a ton. I mean, that's how we won World War II. We were just really good at producing stuff. And then we gave a bunch of money to Russia and supplies to Russia. And we taught Russia how to industrialize. Our capitalists, went to Russia. We explained this is how the manufacturing process works. And then we basically created a great, assembly line system in Russia. But over the years, the American economy has focused more on leadership, global leadership rather than industrialism. And the way I'm defining global leadership is like finance, using information to kind of extract money, outsourcing a bunch of stuff and then just managing it. So America has become a management economy, more or less. But that assumes we control trade. Piracy isn't really a big problem currently. And one of the main reasons for that is because of American military spending on our Navy. If countries started targeting American trade or privateers or whatever, America would be able to instantly crush it. But what happens when you have an entire peer adversary, really cutting off your trade? Every single boat that you send to a country that is producing your widget is destroyed. I mean, that global supply chain that America is built on no longer works. So, point is, a country needs to have some sort of, vertically integrated supply chain that is national, not international. Because international supply chains can be very easily disrupted in a wartime scenario. So, anyway. An international trade economy is really great because, and if you know about economics, you'll realize that there's, a huge benefit towards trade because other countries can produce things, some things cheaper than you can, and you can produce some things cheaper than those other countries. So if you trade, you actually get, it's very efficient. And one, America has currently really, they leverage basically the fact that people in America have a high standard of living and have high standards when it comes to employment. So people in America demand a lot of money and we demand high standards. So, you can't exploit people in America as much as other countries. But other countries basically have slave labor. So, America trades with these other countries to get them to do cheap labor for us. And that's kind of one of the main reasons we've deindustrialized. But anyway, so I've explained to you why a deindustrialized economy doesn't work in a wartime scenario. And I've explained why our boutique economy would only last a couple of weeks. So what happens when America is forced to reindustrialize? This has already happened. This already happened in World War II. In World War II, America had a ton of money, but we didn't really have an infrastructure for building ships in mass, for building planes in mass, tanks, blah, blah, blah. But we quickly took our industrial base and flipped it over towards from producing cars and other things into producing planes and ships and blah, blah, blah. Until we were producing like tons and tons of like freedom ships or victory ships or whatever, and planes, and like it was, we were just overwhelming the enemy with the equipment we had. But it wasn't like that in the beginning of the war. So let's assume there's a scenario where the United States quickly reindustrializes. We use a bunch of our tech in the beginning of the war. Now we're out of tech, and now we need to figure out how to mass produce stuff. How would this even be possible? Wouldn't if we used all our stuff and now we're kind of more or less defenseless, wouldn't China just overwhelm us with their industrial might? Not necessarily, because even if we use up a bunch of our stuff in the beginning of a war, we would still damage China, probably like to a huge extent. Because all it really takes is, if you have a bunch of really good precision strikes, you can probably cripple a larger system if you target the critical weak spots. Like, for example, if you're trying to affect a city, if you just cut the supply lines to a city, you just make it so that, cars can't go in and out or trains can't go in and out. A city only has enough, food and supplies to last around 3 days in the United States. So you cut the supply lines, that city is, falling into chaos in 3 days, unless you find some way to get more supplies into there. Now just imagine this in a factory environment. If you are able to leverage your really advanced munitions to take out a bunch of critical supply chain things in China, it might take them a while to get back, continue to get running. So let's assume that happens. Let's assume that, the first volley buys us some time. What would a long-term economy look like? Number one, I would say that we'd have to kind of we'd have to re-industrialize, number one. And we would have to be able to produce a lot of stuff cheaply and quickly, which would mean our current doctrine would probably need to flip on its head. Instead of spending a lot on munitions, we would spend a little on munitions, but produce a ton. And that means swarm warfare, which China is already very good at, but the United States could probably, I think we could catch up. Okay. Now let's talk about swarm warfare. You guys probably already can picture what that would look like, but basically, what are the different types of drones you could use? The current most common one is a quadcopter. Why is that? Because it has a bunch of redundant stability. It can control where it is in 3 dimensions really, really, really easily. You could do a tricopter where that would work. But the problem is the algorithm would be a little more complicated, and maybe the control system wouldn't be as, the feedback would be a little less stable, I would say. You could do a bicopter, but you would still need probably a motor in the middle. So like 2 propeller blades with a motor in the middle that kind of, like, I don't know if you remember a ripstick in the 2000s, but kind of like that. I'm pretty sure that system would work. But currently, we use quadcopters because it's quadcopters. It's the equations of motion work really well for that. What's another solution? A helicopter drone. Basically, just imagine a helicopter. There's a couple different types of helicopters you could do, but those have less. They're less controllable than a quadcopter, which is why I don't think they're really used as much. But some of the first drones that were made had a kind of a helicopter design to them. And I'm talking about, like, how would you say it? Remote controlled drones. Like the Navy had, I forgot what the actual name of it was, but one of the first drones the Navy had, I think, was in the 60s or 70s. And it was this big old gasoline powered helicopter. It looks really cool. I suggest you look it up. But that's kind of the beginning of this. So you have a helicopter drone. And then the other option is just basically a mini plane. So use a propeller or some other propulsion, and the benefit of that, I think, is that it's just more efficient in terms of going long distances. The problem is that it's not maneuverable. So if a quadcopter is, going towards a moving enemy, and the enemy is running through trees and stuff, or they turn around, if your enemy is very mobile and you need to go in really close, a quadcopter works. If you're using a plane, an enemy runs into a house. A plane isn't going to be able to, like, slow down and turn and, go into a certain room. It's going to, it's more of a glide munition or something like that. It's less maneuverable. So anyway, those are basically the types of maneuverable munitions, right? With different architectures. The problem is that you can't really focus on just one architecture. You can't just say, oh, we're going to do a bunch of quadcopters. Why is that? Because they're not as fast as the planes. They're not as efficient as the planes. But you can't go all planes because then you don't get the maneuverability. But then you also have another problem on top of that. The electronics. So what's the problem with the electronics? If you use something called a maser, which is a microwave laser, you can fry the electronics of a drone or something like that. Or you can use other EM weapons or EW, electronic warfare measures. But basically, a circuit is a bunch of electrons flowing through metal. And how would you say it? That flow of electrons generates a magnetic field, right? And that flow of electrons can also be influenced by, external magnetic fields. And what is light? What are photons? Photons are an electromagnetic wave. So if you shoot an electromagnetic wave at a circuit, at a flow of electrons, you can cause it to, spike up in, you can cause the voltage on the circuit to spike. And the problem with these circuits is that, some of these components are very fragile, especially if you're talking about tiny little transistors. And a transistor is basically just an on and off switch, or something that can amplify a signal. And if these transistors or other kind of small components go outside of their rated voltage rating, then it'll just basically burn out, like you're burning out a light bulb. That's a very simple way of putting it, but these things are very fragile to, electronic warfare stuff. Now, you can harden these things. There are different methods of radiation hardening, rad-hardening or whatever. You can shield a system. But from my understanding, that only goes so far. If you really, really overwhelm it, then, it's very hard to completely make something impervious to electromagnetic radiation. But let's say you can, create a perfect Faraday cage or a perfect shield that prevents all electronic warfare weapons. You're having a trade-off there because you're going to need to invest in equipment to do that shielding. So what does that mean? It means that the cost of each of your drones is going to increase, or the weight of each of your drones is going to increase, or maybe it even makes the power consumption of your circuit increase. And this analysis is called swap analysis, so size, weight, and power. But basically in engineering, you run into all these trade-offs all the time. If you want a new feature, it's going to cost you. The question is, can you make a drone that is super inexpensive, that is completely shielded, and impervious to electronic warfare measures? Probably not. Which is why what you're seeing in Russia right now, and Ukraine right now, is the use of these fiber-optic cable lines. So what does that mean? You have basically a long strand of glass where, gosh, what was the law, Lenz's law or something? Fiber optics is basically you're shining a laser and the laser bounces up and down throughout this cable until it gets to the end, and you don't really lose any information. It's very clear, high bandwidth communication. The traditional way to control a drone is through RF, so radio frequencies. You control it with, basically a audio-visual link to the drone, and you could just, control it like that. The problem is those radio frequency signals can be jammed. You can make it so that the drone doesn't hear it, or you can fry the drone itself. So how do you get around the control problem? You just are directly plugged into the drone, right? Because you can't jam that. You can't. How would you say it? You can't interrupt the light that's bouncing through a fiber optic cable. You can interrupt a how would you say it? A strand of copper, a wire, because you can basically apply a voltage to it through RF or through kind of EM waves, but you can't do that for a fiber optic cable. But the problem there is that it's range limited, right? How long is your cable going to be? Or what happens if you're going through a forest and this drone is chasing somebody around in the forest? It's going to get tangled up and then it's not going to be able to go anywhere. So it provides a little bit of complexity. So what are the solutions to this, right? Radiation hardening, but that increased the cost. Control, right? But that decreases mobility. What are some other solutions? This is a solution that's going to freak you out, but you make the drones completely autonomous and a closed system. So what could possibly happen, and I think Anduril is already working on this, but you just have the drone be able to think for itself. You know, you have a bunch of logic put into it that says if this person has a certain IR signature or whatever, kill or something. I don't know. You basically, and then you could use like some sort of neural net, like a vision model, so that it can navigate itself around obstacles without a human being in the loop. But there's a lot of, basically, then it just becomes a control problem and a computer programming problem. You know, can you make a drone be able to think for itself and work on the battlefield? The answer is yes. But that increases cost again, because now you're putting a computer onto a drone, you know, like a full-fledged advanced computer. And then the problem is you can't use as many. And then but let's say you can. Let's say you can get the cost of that down. Then you still have the electronic warfare problem. You know, what I think is going to happen is you're going to have an arms race of, you know, increasing the shielding, to increasing the electronic warfare countermeasures, to the point where I think that, you know, I think that the shielding might lose. You know, the shielding might just completely lose at some point. You know, you're gonna have something that's so heavy that it just doesn't make sense to have that much shielding. And in that case, you know, your hunter-killer drones are no longer gonna have that much of an effect. So you're going to need to go back to the drawing board. So where does that leave us? I think this puts us in a very interesting position where we start relying on non-electronic circuits. And I think this would, let's say this war goes on for a very long time, and, you know, both sides keep adapting. Where I think this goes is drones relying on, and maybe it does this, I don't know, this is kind of sci-fi thinking, but organoids, or non-electronic computers. So if you can get like a biological, like a lizard brain or something like that, or some other sort of biological entity to, you know, control your drone. And let's say instead of relying on electrical motors, you use gasoline motors, you know. And then, you know, maybe a liquid computer, which exists. They were in cars in the 60s and 70s. That would be something that you cannot easily just fry in the sky. You know, you would need to kinetically destroy those. And the issue is kinetic warfare is a lot harder than EM warfare, because a bullet or another kinetic thing isn't cheap. You know, you need to go into the ground, you need to mine a bunch of stuff, and you need to refine that. And then you need to, you know, forge it into a shape, and then you need to put it into, you know, some delivery mechanism with a propellant. And all of that requires a huge supply chain, and it's complicated and costly. Or you could just make one thing, you know, a laser or a maser, and it can continuously fire. So you don't need to keep building the projectiles. The problem with the laser is it's range limited. So there's a lot of trade-offs for that. But basically, let's assume that, directed energy weapons are no longer the meta, and you need to go back to kinetic projectiles. Then drone warfare gets crazy. Because currently, if the easiest way to deal with like 1 million drones flying in your direction is to just spray them with microwave radiation, and that would probably solve it. But if you can't do that, and you got a ton of these bio drones coming at you, things get crazy. Now, another thing that could happen, and this would be really crazy. I thought about this a while ago, and I think they had some preliminary experiments with this stuff in World War II, but I think current technology would really enable it. But basically using animals as drones. And stick with me here, because this gets crazy. In the past, I think the Russian military would put a mine onto a dog, and they would train the dogs to go under tanks, and then they would detonate the bomb. So one of the reasons I think they stopped doing that is because the dogs ended up going under the Russian tanks and destroyed them instead. So it didn't really work as well as they wanted it to. And plus, you're basically taking out human beings to have to train these dogs and animals, and I don't know. That makes it very inefficient when you need a bunch of people to be doing other stuff. But what happens when you can get a computer to train these animals for you? Like, let's say you have a pigeon, and you just put some VR goggles on a pigeon, and you train it for a couple months to go and fly at an enemy soldier or an enemy tank or an enemy boat or whatever. And you're training 1 million of these pigeons, and you strap an explosive vest onto these pigeons. It could be the case that that's just the simplest way to do warfare. You get some sort of cargo aircraft, and you just drop a bunch of pigeons over enemy territory, and they remember their simulation, where the pigeon is flying around, and if it flies at an enemy, it gets fed something. If the pigeon is flying around in VR, it starts flying towards an enemy. Maybe it gets some food or something, or a dopamine injection or something weird, and it gets rewarded somehow for flying at an enemy. You do that 1,000 times, it's always going to do that if you put it out in the wild. That could be one way that drone warfare goes. It could be that we just build our own little homunculuses of biocomputer drones. It could be that we just perfect radiation hardening technology, and you can do it all digitally. Any of those could happen. And if that happens, maybe we just need to perfect the interceptor technology. Maybe we develop directed energy weapons that are so good that it just fries literally everything, even if it's biological, right? Let's go back. Why would we use a biological organism? Because animals are naturally good against radiation. Not long term, but short term. A circuit is very sensitive towards radiation, but radiation doesn't really, it doesn't affect the actual physical hardware that much, unless it's on or something. But if you have a circuit that's broken, it it's not going to degrade the actual copper significantly. It's not going to, turn it into mush. Whereas with a biological entity, it's going to destroy your DNA. The thing is, though, that it's not going to prevent you from doing stuff. You're still, even if you have like a lethal dose of radiation, you're not going to die immediately. It's going to take you some time. It's going to be painful, but you're still going to be able to function, which is why, a biological organism is better suited for radiation environments, at least for short-term stuff. And why is that? Because, think about the history of life on Earth, a billion years. How many gamma ray bursts hit Earth? How many major solar storms hit Earth? There's a lot of crazy electronic stuff or electromagnetic stuff that, biology had to go through, which means that that we evolved to not be super sensitive to it, most likely. So anyway. So where does this go? I think it really depends on how good we are at interception. If we're good at interception, things go away from drone warfare, drone swarm warfare. If interception doesn't work, that's not good. Like, where does this end up? Where this ends up is basically a huge cloud of drones flying at a country and targeting everybody in that country. Like, you need to imagine like advanced drone warfare as having an impact equivalent to like a weapon of mass destruction or a nuke. This could even be worse than that, because if you have a cloud of these things that are hyper maneuverable and are targeting everybody, which is what would happen in a total war. In a total war, and the United States thought this in World War II, they think that everyone in a country is a target, because even if you're not a soldier, a civilian is helping a soldier. And that's kind of how they conceptualized it. So everyone is fair game in another country in a total war scenario, at least how we fought it historically. So there's no reason to think that an adversary country wouldn't just try and kill every single person in that country. I mean, that's kind of the end goal of one of these wars, right? It's like, we're going to keep killing you until you surrender. I mean, that's what the United States was basically saying with the nuclear bombs they dropped on Japan. The problem with a nuke is, as I told you guys before, it's very inefficient. You're expending a huge amount of energy over a large area, and it's not precise. Plus, it makes that area uninhabitable for a while. And if you do a large-scale nuclear war, and everyone kind of loses. So nukes are not preferred. What a country would prefer is mass precision strikes. And if you make that actually feasible, it gets scarier than a nuke. So how do you counter this? Like, how do you prevent a bunch of these killer drones from killing every single person in your country? You can't shoot them out of the sky. You can't, none of your energy weapons work. None of your kinetic weapons work. Someone walking around on the street, they're walking, and then, one of these, like a drone that can think for itself, says, "Oh, look at that person," blows up their head. Times 1 million, times 10 million, times 100 million. How do you solve that? You make it so that you cannot target people, I think. You make it so that there is no vulnerability. What does that look like? You know, maybe everyone is walking around in these giant mech suits, or maybe everyone, if they have to go outside, they are in like these lead blocks that drive them places, or something like that. You know, if they need to go outside, they're heavily protected. But what about the places where they live? What about the places they work? Your society would basically need to become a fortress. Everything would need to be a concrete bunker, or everything would need to be underground, because that's the most efficient way to protect yourself. Because the further you go underground, the more protection you have. Just because there's so much energy you need to deal with, right? If I'm going to dig a hole, think about how much energy that takes. If I'm going to, you know, if you dig far enough underground, you can even prevent, you can even survive nukes. So dirt is a very OP defense against this type of stuff. So let's say you see that happen. Let's say in order to combat drone swarm weapons of mass destruction, people convert their entire supply chain, their entire way of life into underground societies or bunker societies. Then what happens? Then you see interesting things occur. Then you try and kill. Then a country would try and kill the people in the bunkers somehow. And if you can't use drones, the options become much more limited. I think things would start going into chemical weapons or biological weapons. And it might even get into nuclear territory, like practical nuclear weapons, like en masse. Because if you're underground already, if you're underground, you're protected against the fallout. So a country might not actually care about starting a mass nuclear war if it gives them some chance of destroying their enemy strongholds, because they're already protected against it. Maybe an enemy country would say, okay, well, let's just put poison gas on the airflow inlets to these bunkers, and that would solve it. Or maybe we need to just find a way to, get pathogens in there. And then that's a terrible scenario. Like imagine the 12 Monkeys, that movie. Imagine a scenario like that. And then the solution for that would just be to go even deeper, or to make your bunkers completely self-contained. And I think that leads to the final stage of really advanced warfare. It's 2 stages, actually. Stage 1 is extremely autonomous weapons. So instead of just having a drone that can do one thing really well, it can fly up to a person and blow up. You need to have generalist robots, or a ton of robots that do a bunch of complicated things, or a bunch of tasks that perform complicated engineering projects autonomously. What does this mean? It means that you need to have a way to get into these impenetrable bunkers. You basically have a robot army that goes and figures out a way to tunnel into these bases. So imagine the surface of the planet is completely inhospitable for human life. And these automated factories are sending out weapons and stuff. The surface of the world is just like, swarming with these robots that are trying to kill the enemy. Where it ends up is, these robots are now trying to tunnel into these underground bunkers. And then at some point, maybe it's that technology gets so good that even underground bunkers don't work, right? They tunnel down, they put in poison gas or some pathogen, and then everyone's dead. And you'd think, oh, that's game over. Yep, it's all done. There's nothing that we can do to that. But no, it's not all over, because there's a solution to that as well. And I think this is where it's just steady state. It's over. Like there's no counter to this. The complete solution to this warfare problem is space habitation. I think what you'll see is these countries creating colonies in space that are basically, are basically an example of those countries fleeing, chemical warfare and maybe fallout and maybe biological warfare. Because in space, there's no air that, you don't need to worry about the air. Everything is completely self-enclosed. And it's much more maneuverable in space. Underground, you're kind of stuck. You don't get to retreat. If the robots are tunneling down, where am I going to go? I'm just going to go further down. No, you don't get to do that. It's basically game over. But in space, you have a habitation, but you're also maneuverable. So what does that mean? Or your counter to that would probably be, well, then why don't they just, shoot down the space stations? Number one, because you could do kinetic interceptions. And because movement in space is a little bit easier. But assuming you can't intercept, then the solution is just to run away. And basically what you would do is you would have human colonies just fleeing from each other. They collect a bunch of materials and stuff, and they say, okay, we're just going to keep running. And if we run away fast enough, then, then they can't harm us. And you could say, well, then you just have a weapon that goes faster than those spacecraft. And sure, that could be the case. But if you accelerate to a sufficient speed, there comes a point where, and it's called the light cone. The light cone is basically the furthest you can have an effect, or the furthest distance, or the furthest sphere of influence of yourself. So what this basically means is, what's the physical limit of how far you can affect the universe? And how this is calculated is just like imagine an orb emanating from yourself at the speed of light. The speed of light isn't just like the speed of light, it's the speed of causality, which is why it's called c. And what that basically means is, the furthest, or how would you say it? The speed of light is the physical limit at how fast you can affect something else. So the light cone is basically, what can you actually affect, right? Even okay, let's say this lamp right here. I can affect it, but, can I affect it instantly? No. If I were like really, 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 really fast, I could affect it at like 99.9% the speed of light or something like that. But it would still take time for me to affect it. And at some point, well, actually, if I wanted to affect this, like instantly, it would be impossible. But at some point, like if it's stationary and if I'm moving towards it, I can affect it. That's kind of how the light cone is. So the more time elapses, the more things in the universe you can affect. But it requires you to, move fast to do that. But that's the theoretical limit, right? So let's go back to I'm not explaining this perfectly, but the point is, the light cone is a way of understanding what you can actually have an effect on in the universe. And if you go fast enough, and if you are far enough away, you make it harder and harder for someone else to affect you, number one. And if you are outside of the light cone of somebody else, or the realistic light cone, so let's say some percentage of c, so an even slower speed, right? Let's say the maximum you can go, for all intents and purposes, is like 0.5 c. So imagine a smaller light cone. If you can get outside of that smaller light cone, then for all intents and purposes, they can't affect you, which means that is like the perfect defense. Anyway, that was a clumsy explanation, but my point is that's like the ultimate way of ensuring that you don't die to really, really, really advanced warfare. You just run away so fast that they can't catch you. And since space is effectively infinite for all intents and purposes, or practically infinite, or almost infinite, or whatever, or it's so big that the scale doesn't even matter, you can run away forever. But anyway, if warfare were to proceed to its logical conclusion, I think that it would end there. And the takeaway here is that even if things got really, 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 really bad, there's still a way around it. There's still a way for life to survive. Yeah. So where does that leave us? Number one, if a major global war is imminent, it would be a good idea for us to invest in underground infrastructure. And it would be even better for us to also invest in space habitations. It would also be very important for us to invest in the ability to mass produce stuff, mass produce drones and things like that. And at the end of the day, you know, there's really two scenarios. Either drone warfare is the ultimate form of warfare because there's no escaping it, right? If it's very hard to intercept these drones, then that's the ultimate weapon of mass destruction. But if that's not the case, if you can nullify drones, then it gets to be just very simple. It goes back to your classic nuclear, biological, and chemical weapons. And then you go into space, and then I think it just turns into a matter of, building weapons that are, for all intents and purposes, impossible to intercept. Like what's a weapon that's impossible to intercept? A relativistic weapon, a relativistic kill vehicle. So basically, you accelerate something too close to the speed of light, and that is your bullet. Number one, you have very little warning if a relativistic bullet is coming at you, because there's light coming off of this bullet, and you see the light. How quickly can you get a turret to like target the location of the bullet or something like that, to send your own relativistic bullet at it? It's going to take time, and then at that point, is it going to be able to even? Well, maybe not. Maybe it could actually target it, because you get to see it from way far off. So ultimately, no, the interception problem isn't really an issue, because you can just shoot their bullets with your bullets. The main problem there is if you are a spacecraft that is fleeing from an industrial factory, that industrial factory has a bunch of materials it can use. So like imagine you're a spacecraft flying away from a hostile planet. It's a mass problem. That planet has a planet's worth of mass, and you only have a spacecraft. They're going to be able to produce more relativistic bullets than you can produce counter bullets, which means that they win in the end. So anyway, it still gets back to the original light cone thing. If you can just get out of the sphere of influence of an enemy, then you win. But yeah, the main problem though is accelerating a sufficient mass gets to be a huge problem. So yeah, maybe you actually lose that, because if you need to accelerate your civilization away from somebody, that's going to require a lot of energy, and it's less energy to send over a weapon than it is to launch an entire civilization, which maybe gets to the point of you need to send out your influence rather than your civilization faster than the other guy can, which maybe goes into von Neumann probes, which are basically self-replicating, self-assembling machines. So if you can send out a tiny little machine that can build up an entire civilization before the other guy, maybe that's the solution to it. Send an embryo and a device that can build a factory that mass produces embryos or something. I don't know. But I don't know. That's you still have the problem with the mass though, because it's lower cost to build a bullet than it is to build a complicated machine like a von Neumann probe. So, I don't know. The solution is to send out your guys early. Because if you're far enough away and you accelerate for a long enough time, then maybe they never catch up with you. Yeah. I don't know. There's probably an area that I'm not looking at here, but well, you would have to have two groups of people that really hate each other to have them go to this extreme. I don't know. The good thing about human beings is I think war isn't really, I mean, to some extent it can be genocidal, but to another extent there is it's like a pressure release valve to an extent. War doesn't exist to kill everybody in many instances. It exists to, impose your vision on the world. Like Napoleon wasn't trying to genocide Europe. He wanted his idea of Frankish nationalism to prevail. So even if the weapons technology means that life is on the losing end of things, I think there are safeguards in how human beings actually approach war that make it not really an apocalyptic threat or an inevitable apocalyptic threat. So really the main threat then is non-human war. If you have an artificial autonomous agent conducting warfare on your behalf, maybe, then it starts leveraging non-human motivations. And if you encode into a general AI or something like that, you need to kill every single enemy under all circumstances, any and all circumstances. Stop at nothing. I don't know. Then that might end up with this, autonomous general sending relativistic bullets at a fleeing generation ship. And then that's the end of humanity, maybe. So yeah. A lot to think about. Anyway, I think I've gone over enough details, but who knows? Maybe the technology changes. Maybe the metas are different. But I think given the current state of physics, I'd say that this game theory, hypothetical, holds up. But anyway, if you enjoyed, please let me know what other things I should talk about in the comments. And I hope you found this interesting. And I'll see you guys in the next one. Peace out.